All right, so here we go. Real number system. Guys, this is like one question on the exam, so don't stress. Literally one question. This is almost useless.
At least said that they're going to make it a whole entire section.
Numbers that can be written as a quotient of two integers. What does that mean? Fractions. X over y. All these numbers all end or repeat. You really shouldn't need to write that down. Irrational numbers cannot be written as a quotient. They neither end nor repeat.
Susanna, I didn't have one of those.
She printed it off the internet because I made it available.
Right,
Yes.
that's where it was.
On my OneDrive. This one is most likely going to be a non-perfect square. Anytime you have a non-perfect square, you've got an irrational number. Please remember this officially only appears to be irrational. Factors. These are not important on your provincial by themselves. They are important on your provincial as a tool to use for other things. Okay? These are how you find lowest common denominators. These are how you do factoring of trinomials. And it is also how you simplify radicals. So please make sure you are comfortable with them. GCF is greatest common factor. When do we use that? Mostly in factoring trinomials. In factoring polynomials. We're going to use it a lot. And lowest common multiple, when do we use that? That's in finding common denominators, which is really useful in converting measurements. Yes? So, there it is. Oh, good gravy. Sorry, guys. There is how to do it. Now, if you are bad at it, you may want to now, on a piece of paper, LCM and GCF, and I'm going to do these two, that are not hard, but again, they follow the same rules. So, find the factors, use those primes. 18, 2, 9, 3, 3. 24, 2, 6, 2, 3, not 2, 6, 2, 12. 4, 3, 2, 2. What do you have there? You have 2 times 3 squared, and you have 2 cubed times 3. LCM in red. Count everything once. 2 cubed covers all the 2's. 3 squared covers all the 3's. 72. GCF in black. What's common? How many 2's are in both? 2. How many 3's are in both? 1. So it's 2 times 3, which is 6. Okay? Everybody good? Come over here. 35 and 210, 35. 7 and 5, super easy. 210. Oh my good gravy, that's a giant number. Start small. Divide by 10? Sure. 10 and 21. 2, 5, 3, 7. LCM. Count everything once. 2, 5, 3, 7. Does that count everything? Great. So obviously 2, 5, 3, 7, 210 is the LCM. Because 210 times 1 is 210. Right? Now, if that's the LCM, then automatically what's the greatest common factor? 35. Has to be. Right? Because if 35 will multiply to 210, then 35 must be a factor of 210. And 35's biggest factor of itself is 35. Everyone okay with GCF and LCM?
Yeah.
You taking the picture there, Kashish? Do you want me to photobomb it? No? Okay. Mixed radicals. Okay. 2 seconds. Mixed radical has a coefficient and a radical. Entire radical, no coefficient. You must be able to go back and forth between the two. Making an entire radical mixed is called simplifying. If there is a 3 out here, how many 3's were under there? 2. How do you know it's 2? Because the index is 2.
5 times 3.
So that means there were 2 3's in there. What are the 2 3's doing? Multiplying. So this is the root of 5 times 3 times 3, which is root 45. This one is the root of 10 times 7 times 7, which is root 490. What is different here?
It's a 3.
Root of 3. Of course, you can do a shortcut. That index, you know, is also an exponent. So that is the root of 3 times 2 cubed. 2 cubed is 8. 8 times 3 is the cubed root of 24. Does everybody remember radicals?
Yeah.
Awesome possum. To simplify means break them up. Remember, this, break them up into a perfect square, that's the shortcut. Okay, that's what you do when you get good at this. You can also product of prime them, just like your GCFing. All right? So this one, I'm going to do the long way. 54, 9 and 6, 3 and 3, 2 and 3. Yes? So this, root of 54, is also the root of 3 cubed times 2. Yes? I need a group of 3, yes? Or a group of 2. Do I have it?
Yes.
Yes, right here, there's 3 3's. So I'm going to bring out one of those 3's, which covers a group of 2. How many 3's are left under there? 1. 3 times 2. Is that simple? 3 root 6. Everybody cool? That's the long way. Will that work every time? Yes, 110% always. If you know that, you can do every single radical question I will ever give you. And every single radical question you will ever get. However, there is also a shortcut. When I look at 45, I don't see 45. I see 9 times 5. And I right away see that 9 has a square root. What is it? 3. 3 root 5. Okay? Okay? 108. Which way are you going to do it?
9 and 12.
9 and 12?
3 and then
Okay.
yeah, 3 and
So you see 9 and 12, right? That's good if you see 9 and 12. So 5 root 9 times 12. And then what do you see in 12?
4.
4. So it's 5 root 9 times 4 times 3. What's the square root of 9?
3.
3. What's the square root of 4? 2. What was already out there? 5. What was left under there? 3. 3 times 2 times 5, 30 root 3. Everybody remember this?
Yeah.
Sweet. This one. Multiply. Now, Again, some people say, I don't know how to multiply these. Yes, you do. You absolutely do. What is 2? If this was 2x times 4x, what would you have?
6x.
8x squared.
Oh.
So, 2 times 4 is 8, and you would do x times x to get x squared, yeah? Well, here you're going to do 7 times 12 to get 84. And then you would simplify. Right? 84 is, of course, 12 times 7. Right? Or 4 times 21. 8 root 4 times 21. Does 4 have a square root?
Yeah.
What is it? So it is 16 root 21. Cool? Now I'm going to do one more hard one to make sure that everybody understands this. All right? 3 root 54 times 4 root 45. Now I use 54 and 45 because we got them right there. If you just follow this pattern, you're going to get a crazy number, aren't you? You're going to get the 12 times the root of 2,430. And then you're going to have to simplify that.
Simplify it now.
Simplify first. You've already done this one. It's 3 root 6, right? And what's out in front?
9.
3. So this is 9 root 6, yeah? This one is 3 root 5. What's out in front? 4. So it's 12 root 5, yeah? Now, 9 times 12, 108, which we had right here. It's like how I did that. 6 times 5, root 30. Does root 30 get simpler?
Yeah.
No.
No.
2 times 3 times 5. No pairs. Everybody good? What's the key verb for this entire section of your provincial exam? Simplify, simplify, simplify. If you can simplify, do it. When? Every single time you can. Got it? Addition? It's the same as 3 root 7 plus 4 root 28. You can't add them. Why? Because that's x and y. So what do? Simplify, simplify, simplify. 3 root 7. This is 7 times 4, isn't it? What's the root of 4?
2.
So it's plus 8 root 7, right? Now you got 3 root 7s and 8 root 7s. For how many root 7s? 11 root 7. In my head, Or-
Could I see LCM and GCF? Like, I don't understand how that
Then
works.
no.
So.
come back and see me. Or wait and make sure I get through all of this. Exponent rules. We did this last day, right? I'm not going to review all the exponent rules in any way except to show you them very quickly with letters. X to the y times x to the z, x to the y plus z, x to the y divided by x to the z, x to the y minus z. Oops. X to the y all to the z, x to the y times z. X to the 0 equals 1. X to the 1 equals x. 1, 2, 3, 4, 5. 3, excuse me. X to the y to the z is x to the z, right? X to the z, and, oh shoot, I needed another variable there to do that right. Sorry guys. X to the y, z to the a is x to the y times a and z to the a. That a goes everywhere. Okay? And what would be the seventh? Oh, negative, thank you, yes. X to the negative y is 1 over x to the positive y. And its partner, 1 over x to the negative y, is x to the positive y. So, coming down to here, you're all bad at exponents. I would recommend having a look at this. That 3 there, every single one of you will do K9. Woof.
6-3 K9.
Every one of you will do K9. Half of you will forget 6 cubed. Okay? Easily half of you will forget the 6. So that is 6 cubed k to the 9th times, same thing here, 2 cubed k to the 6th. 6 cubed is 216 k9, woof. 8 cubed is 8k6. 216 times 8 is 1600, 1680, 1916, isn't it?
She's a little big.
What is it?
1,728.
1728. 1728 k to the 15. Because it is 9 plus 6. Okay? Now here, you have all kinds of choices. I cannot do this in all the ways you could do it. So I'm going to do it the way I think is the easiest way for you guys to do it. Distribute that negative 3. 2 to the negative 3, x to the negative 6. Times negative 3 to the 3. What's negative here? The base. So is it going to move between denominator and numerator? No. And x to the negative 12. Right? Now simplify again. That's 1 over 8 and x over 6. Yes? Because the negative moves down. Times negative 27 up top, and the x moves down. What's 1 times negative 27? Negative 27 over 8. What is 6 plus 12? 18. And I'm done. Unless I can simplify the fraction, which in this case I cannot. Okay? Is everybody good with that? The only other thing you might consider is here you might go negative 6 plus negative 12 to get your negative 18 and then moved it down. Please remember, it is a lot of personal choice when you are solving this. Right? Just like if I asked you to paint a room, there's a lot of personal choice that goes into it. There's certain stuff you have to do, but a lot of it is personal choice. Color, brush style, roller, whether you do the edges first or after, whether you get one of those cool edging tools or not. All that stuff is up to you. Okay? Fractional exponents. We did this yesterday when we went over it. Numerator becomes the index, or denominator becomes the index. Numerator becomes the exponent. 4 through to 16. 2. 2 cubed, 8. What about this one? Same thing. If it was 16 over 1, it would be the square root of 16 to the third power, wouldn't it? If it was 25, it would be the square root of 25 to the third power, wouldn't it? But it's both, because of course this exponent goes everywhere inside the brackets, doesn't it? 16 to the 3 halves over 25 to the 3 halves, which is the square root of 16 cubed over the square root of 25 cubed, which is a 4 cubed over 5 cubed, which is 64 over 125. How do I make it seem easy? Because everybody says, oh, Mars, you make it seem so easy. It's only because I have the stuff memorized. Remember how I told you that memorizing your first 5 cubes would be really helpful? And I have the first 10. And memorizing the first 10 squares would be really helpful. I have the first 20. It makes my life easier. Do I need it? No. Just like you don't need that cool tool to edge when you paint. You can just use a brush if you have a steady hand. But from years of video gaming, I do not have a steady hand anymore. I'm twitchy.
What was that game you played? No, the one that you like knew everything on, every single puzzle.
Monsterland.
Yeah.
Mars, you change a 3 to a 2. See that over there?
Where?
On the bottom. It was a 3, and now it's a 2.
That's a 3. Right there where I'm highlighting. It's a 3, trust me. If you got close enough, you would see that I went in bigger. If I drew it bigger, I'm going to zoom in. This is a good use of time.
You literally just thought I'm typing. Oh, I see 3.
See, you can quite plainly see I went over, down, over, over.
Because
Like Zorro.
I don't get it.
Zorro.
you guys have never watched Zorro?
No.
Zorro
Nope.
with the sword.
Wait, Zorro was in the Cinderella story, and they did that Halloween dance.
Rez, it's not anime.
Go home. Get ready, though. Yeah, I am ready.
Change these around. The index becomes the denominator. The exponent becomes the
Oh
numerator.
my god, that was so
X to the 3 halves.
Oh wow, I just found it.
Good? We'll all slow down for Kashish. There we go. Measurement. Do you have to memorize any of this?
No, it's on.
Why?
It's on
It's on the
the data book.
data book. What do you have to memorize?
How did
It's what we want
Divide.
over what we have. Okay? So I have 285 centimeters,
Divide
and I want meters. So what do I want?
you want the number that
I want meters, right?
you
So it's meters over what I have, centimeters. 1 meter is 100 centimeters. 285 is over what?
what?
1. So it's 285 times 1 divided by 100, which is, of course, 2.85. Now, some of you are able to do some of those in your head. That's fine, but you should still know the method, because when you're going from standard to metric, you can't do it in your head, which is what we're about to do, yes?
Yeah.
450 pounds, that's what I have. 450 times, what do I want? Kilos. So I go to my chart and I see 1 kg is how many pounds? 2.2. Close. Let's just check. I'll show you. Go to your data booklet.
In case you're wrong.
I'm not.
There it is. In the middle.
Okay.
1 pound, 1 kilo is 2.2 pounds. So that is 450 divided by 2.2 for whatever it is.
It's like
Okay? It's going to be around 225.
yeah.
Now, of course, you would estimate that, wouldn't you?
Yeah.
Now, this one is hard. Why? Because on your data booklet, there is no yards to centimeters.
There's inches.
So you go yards to meters, meters to centimeters. Can you go yards to inches, inches to centimeters?
Yeah.
Can you go yards to feet, feet to inches, inches to centimeters? Can you go yards to miles, miles to kilometers, and then, yes, there is more than one way to skin a cat. Of course, I would do yards to meters and then just move the decimal place. Right? So I go to my data booklet and I see that yards, 1 meter is 0.9136 yards. Maybe. 1 meter. 9144. Oh, Myers, you're such a disappointment. Because she just called me a moron. Of course, if we reverse the situation, I'd be fired.
You called me a moron. I'm sure you called me a moron.
Never. I've called you a muppet. There is a difference.
You called us cabbages.
Huh?
You called us cabbages.
I love cabbage.
All right. So, I have 250 yards. I want meters. So it's 0.9144 meters over yards. When you do that multiplication, you get an answer of...
A number.
Never mind.
Probably have my calculator out.
Who's going to give your math skills?
Can't do that in your head, Myers.
228.6 meters. I want centimeters. So how many decimal places does it move from meter to centimeter? 2. 1, 2. 228,600. Now, is that a real life measurement?
Yeah.
Obviously.
Really?
That's the wrong.
Yeah. Because in the Olympics, they run the 200,000 centimeter run. No, they run the 200 meter.
No, say sweat.
Convert measurement to centimeters. Of course, you don't need to do that because they have a chart when you go there. When you say you're 5'9", they can't convert it either. They go to the chart. But what it really is 5'9" inches tall to convert to centimeters. Now, there's a few ways you could do this. You can go feet and inches to total inches and inches to centimeters, couldn't you? Couldn't you also do this? Isn't 5 feet 9 inches 5 9/12?
Yeah.
Sir.
Which isn't that 5 3/4?
Yeah.
Which isn't that 5.75?
Yeah. Oh.
And then couldn't I go feet to meters and move the decimal? Again, does it matter?
No.
No. Most of you would probably do feet to inches, 60, plus 9 inches, 69 inches, times 1. I want centimeters. So times 2.54 centimeters over 1 inch. And I get 175.226. Of course, if you've been paying attention, you would know that that's what I give my height as, even though I'm really only 5'8".
You know your secret.
I'm really only 5'7 3/4".
Probably shorter than that.
I am short, but that is okay because I am faster and stronger than all of you.
I'm probably faster than
No.
Race you. Let's go.
I'll race you.
Right now.
you. Who cares? Little Rain didn't kill anybody.
Go in the hallway.
Volume, guys,
Yeah.
listen to me. Almost every shape has a formula for volume. Almost every shape. Most of you are memorizing the formulas. I cannot stress this enough. Every volume is the area of the base times the height. So in this case, the base is the bottom, which is 12 by 5, and the height is 3. So in this case, it's 12 by 5 by 3, which gets us 180, right? That has evolved into length, width, height. Okay? If it's a cylinder, it's base area times height. What's the base? A circle. So it's pi r squared times height. That is where we get the actual formula from this basic formula. Okay? Everybody good? Now, if it's a pyramid or a cone, it's still area of base times the height, but you divide it by 3. Okay? The hardest question they will ever give you is this. What did I just draw? A triangle pyramid.
Oh no, that's mean.
How many sides are there?
4.
I don't see the dimensions on. Oh, okay, yeah.
So a triangle pyramid is still a prism. So it is the area of the base times the height divided by 3. But the area of the base here is a triangle, which is base times height divided by 2. That is the hardest question they can ask, I personally think. Because you want this bottom, if they gave you dimensions, if they said this was 90 degrees, and they gave you the dimensions of 3 and 4, you want this to be a square on the bottom. You're going to do 3 times 4. And forget to divide by 2. Okay?
Oh, that's half of,
The other mistake you're going to make is you're going to call the slant height the height of the thing. If you walk up the side of Mount Everest, that is not its height. Okay? If I took a tape measure and I ran it up my body, following the contours of my muscular thighs and my Popeye arms, I would be taller than 5'9". But that's not how we measure height. We measure height straight up the middle, through your liver and all your guts. Got it? Don't make that mistake. Your slant height is not the height. If it seems too easy, it probably is. So check and make sure you are not using the slant height when you want the height, and the other way around. You are not using the height when you want the slant height. What mathematical tool finds you the slant height?
Oh, the Pythagoras.
good old friend Pythagoras.
Pythagoras for slant height or unknown regular height. Okay? Surface area and volume of the cylinder. Do I need to go through it? It's just a formula. SA 2 pi r squared plus 2 pi r h. Right? 2 pi, what's r? 2 squared plus 2 pi, 2, 10. What's the mistake you're going to make? You're going to go to your calculator there and start punching in pi.
Can't do that.
Bad mistake. What's 2 squared?
4.
What's 4 times 2?
8.
8. 8 pi plus 40 pi, 48 pi. Now you go to your calculator. How do you get that from your calculator?
48 pi.
Either 48 times pi equals or 48 pi button equals. Then you get your answer. Got it? And of course, volume, area of base times the height. V equals pi r squared h. Pi 2 squared 10 40 pi. Then you go to your calculator.
That's be like 120.
Now, next thing is exactly what Corbin is doing. Before you go to your calculator, you in your head say, isn't 48 close to 50?
Oh, that's really good.
50.
Isn't pi close to 3? So this answer had better be around 150, right?
Yeah.
Then if you screw up punching it in and you don't get something around 150,
You're 10.
you're not going to circle something. All the choices are going to be there. The one closest to 150 is probably going to be right. Okay?
That's true.
Unless you screwed up the equation somehow.
Why we should put
How can you screw up the equation? You get the equation.
Some people just.
The equation is there for you. Surface area,
Alright.
volume, area of base times the height. It is impossible to do these questions wrong. I do not know why kids don't get 100% on surface area and volume. I don't understand it. When I was your guys' age, it was possible to make mistakes because we didn't get a formula sheet, we didn't get a picture. It was all words. You have a pyramid with a slant height of 12 and a base of this and a width of this. What is the surface area? You guys get the picture. And they give you the picture on the formula sheet. All you got to do is say, oh, that's slant. I know he's kidding. It's okay. I know he's joking. I had to take a second to make sure because it came from the back corner and it could very well have been a real question.
Oh, we just did this.
We just did this. Do I need to go over it?
No.
6 minus 3, 4 minus 2, 3 over 2.
Hold on.
Given the slope, 4 over 7 equals 1 minus 7 over x minus 4. Crisscross. Negative 42 equals 4x minus 4. Minus 16. Plus 16.
Negative 26.
Thank you. Negative 26 equals 4x. X equals negative 4.5.
You do this differently.
6.5. Because 4 goes to 26 6 times.
I can't watch you do these questions because I do it differently from you, and then when I watch you do it, I get confused.
How do you do it differently?
I don't know. I arrange my numbers differently than you. And then,
Okay.
Or you skip a step or something, but I don't see where you.
This
how you
one,
get to where
same
you go.
thing. The slope is 2. What is 2 really? 2 over 1. I'm going to reverse this time and make these guys y2. So it is 1 minus y over 0 minus 5, which is negative 10 equals 1 minus y. Minus 1, negative 11 equals negative y, so y equals 11. Okay? Yes, in Honors Math 10, adding and multiplying is very difficult. I agree with you 100%, he said sarcastically. Uh-huh. Obviously.
But Aaron doesn't show me. Which that is not joking. Oh,
M
no.
M is what?
The slope.
Slope. It is also rise over run. So if there's a fraction somewhere in your equation, it's your slope. B is the y-intercept. Y-intercepts are all what?
Numbers.
0, comma, y. It's point slope form. M is the slope. X1 and Y1 are the points. What's the warning? What do you have to remember?
Points. Oh, is this
They're opposite.
Why? Why are they opposite?
Because, Kashish, if you have this, y minus 7 equals slope of 1,
Okay.
x plus 3. To solve this, to make them equal, I would use 7 minus 7 to get 0, and negative 3 minus 3 to get 0, right? 7 minus 7, and then 0 would equal 0. So the points on the graph are actually x and y, but we use these points to find what they are. And the shortcut in our heads is it has to be this, but opposite. Okay? This one is general. This one is standard. Find the equation that goes through these.
Hi.
What do I have here?
Points and
A point and a slope. So what do I use?
Points over.
Point slope form. Y minus 1 equals 5x minus 1. Done. What do I have here?
Slope intercept forward.
I have a point and a y-intercept.
Use slope.
Yeah. Does that fit anything?
Not
I don't have a slope, so I can't do slope-intercept. I don't have a slope, so I can't do point-slope. So what do I do when I'm stuck on a coordinate geometry question?
graph it.
No. You could graph it. Option 1 is graph, because you get graph paper. What's option 2?
Figure out the
Figure out the what? Slope, always. Do you have 2 points to do slope? Yeah, you do, because the y-intercept is what?
12.
0, 12. There's an x and a y, isn't it?
there's an X.
And there's an x and a y, isn't it? So, 12 minus 13 is 12 plus 13, right?
Okay, you gotta write it out.
So I got 25 over
0.
0 minus 5, negative 5.
That's negative 5.
So my slope is now negative 5, right? So now I have a slope and a point and a slope and a y-intercept.
Slope intercept forward.
So it's y equals negative 5x plus 12, or y plus 13 equals negative 5x minus 5. Okay?
Call it a day.
You're smart.
Thanks. I try.
I'm sure you do.
Find the equation of the line that goes through those 2 points. Before you find an equation of a line, what do you need? Slope. Once you have slope, you're in business, right?
Yeah.
Once you have slope, you automatically have 2 equations for this line, don't you? Because you have 2 different points. And 2 different points. So what's the number 1 thing to do?
4 minus what?
Always find slope. Always be finding slope. 4 minus 2 over 3 minus 1. 2 over 2. Slope is 1. So y minus 2 equals x minus 1. Right? Or y minus 4 equals x minus 2. Right? Officially, those would have brackets, and we put a 1 there for our slope of 1, wouldn't we? But we don't need a slope of 1, because we're not stupid. What about this one? 2 minus 1 over 2 minus 1. 3 over 3. Same slope of 1, right?
Yeah.
And then I would do the same thing.
There's a thunder out there.
What was that sigh for?
That.
Just right here.
I know I live in the south coast of Canada. I know I need to be aware of that as the constant in my life from the end of October until the end of May. That doesn't mean I have to be happy about it. Right? When I lived in Williams Lake, I had to be aware that from Halloween till the end of May, there was snow on the ground. I wasn't happy about it.
Really?
Yes. No. You love snow because you don't have to drive and you don't have to shovel. So you love snow.
I shovel snow.
The people that have to drive and shovel it hate snow. And snow here is once in a while. Snow every day for 6 months sucks. Because when it's not snowing, it's also minus 20.
Isn't Williams Lake the place where you started like getting into math?
Started what?
Is it was getting into math like after?
Williams Lake was my first job.
Yeah.
All right. What is the key word in example 6? Parallel. So what's got to be the same? That slope. So what's find slope? M is 2. Do I have a slope? Do I have a point? So what's the equation? Y 12 equals 2x minus 10. And then what must you be able to do? Convert. Just in case. To general, standard, and slope intercept. What about this one? Perpendicular. What's the slope I have? What's the slope I need? Negative 1/9. So, and a y-intercept of 3, which gives me a point of 0, 3, yes? So, y equals negative 1/9 x plus 3 for slope-intercept form. Y minus 3 equals negative 1/9 x, point-slope form. Cool? Determine the x and the y-intercept. X, 0, 0, comma, y. And sub back in. I am down to 8 minutes. Okay? Listen to me, I'm going to stop. Listen. So, we are at polynomials and factoring. Grade 9 stuff here. You already know this. There will maybe be one question on the whole provincial about it. Okay? So, if I have 3, I got 3 little boxes. If I got negative 2x, I got to have 2 colored in bars. If I got 1x squared, I got to have 1 big white box. Okay? That's it. You guys already know how to do that. You're going to do FOIL. Hopefully the smarter ones of you that remember it are going to do the shortcut. 2 minus 1, 2 times negative 1. But of course, the question is asking you to sketch the algebra tiles. Now, how will they do that on a multiple choice exam? They'll show you 4 different diagrams of algebra tiles. You got to circle the one that's right. Okay? So, one side is x plus 1x, dummy, x plus 2, and the other side is x minus 1. And then you just fill in the middle. 1 big x squared, 1 negative, positive, positive, and 2 negatives. Done. Everyone remember that? Do I have to spend any more time on it? No? Okay. Lovely. This is what properly? What is this really called? Starts with a D.
Distribution.
Distribution. Okay? It's important to know those real words, because if you get one of those questions like, Joey did this, where did he make a mistake? And they write it out. First thing he did was distribute the coefficient through the entire polynomial. If you don't know what distribute means, you don't know what's happening. Okay? That is why, once again, I don't have cute little pet names for everything in math class. I call it what it is called. Okay? So, distribution, you get a little double exponent practice here, don't you? What is this first one? 2 x cubed minus 6x. What's this one?
Negative 2x squared.
Minus 6x minus 14x minus 7 plus 3. Then I have to collect my like terms. Any other x squareds?
No.
No. Negative 2x squared. Done. Any other x's?
Yeah. 14.
Negative 14, 6 minus 14. Negative 20x. Done. Negative 2, negative 7, positive 3. Negative 6. Okay? Everybody can do that? It's still grade 9. But it's in your grade 10 curriculum. Now, if the shortcut screws you up, should you try to use it? No. When are you allowed to use shortcuts in any path of life? Anything you are doing, when is it appropriate to use a shortcut? When you already know how to get there the long way. Do you understand what I'm saying?
Yeah.
If you cannot do FOIL here, do not try the shortcut. Okay? Now some of you already know this answer is x squared minus 8 minus 20. Right? Some of you. Some of you don't, because you don't get the shortcut. So you're going to do the math. What if the word FOIL falls out of your head? I don't know what to do here. But you do, because this is just x times that, isn't it? Plus x plus 2 times that. That's all it is. If you can do 2x minus 20 and x times x minus 10, then you can do this. The way I taught you to help you is FOIL, and then I taught you that other shortcut. X times x, x squared. X times negative 10 minus 10x. New term, new line. Plus 2x. Keep your x's together. Minus 20. X squared, negative 10 plus 2, negative 8x minus 20. Okay? Same thing here. 10x squared plus 30x plus 10x plus 30. 10x squared plus 40x plus 30. Right? What about here? 4x squared plus 8x minus 6x minus 24. 4x squared plus 2x minus 24. Now this one messes you guys up. What? Maybe. Where?
When you distributed the 2x to 8.
Yeah. Yeah, it should be 16. Here.
No,
It'd be 24.
it's 24.
The 6 must be 16. That one must be 24.
Because it's 3.
2 times 2 is 4. 2 times 8. Yeah, that should be 16x. Right. So 10x, and that was 24. Hey, everybody caught it, which means you can all do it.
Yeah.
Right? So I better not see anybody get a FOIL question wrong on the exam. Because everyone caught my mistake. Everyone loves catching my mistakes. No problem making your own. But if I make one, it's okay. I'm cool. I got broad shoulders. I can take it. This one is where you're going to screw up. Because every one of you is going to say, I know that. That's an exponent law. That's x cubed minus 125. Aren't you? No, of course you're not. Because what's the base there? X minus 5. So what is repeated thrice? X minus 5. So that is x minus 5, x minus 5, x minus 5. Right? I always do the second two first. That's just the way I like to set up my paper. X minus 5, x squared minus 10x plus 25. Then I do this. First term, x cubed minus 10x squared plus 25x. Second term, minus 5x squared. Keep the x squareds together. Plus 50x. Keep the x's together. Minus 125. Collect your like terms. I will wait a moment. People in the other class were taking pictures of the screens with their phones when we were at a point they needed to double check. You are welcome to do that, but be aware this video is online. Okay? Everyone all right? Sweet. Factoring. GCF. What's the GCF? Kelvin.
3x.
3x squared.
Oh, yeah.
Okay? So GCF always ends up looking like this. The GCF multiplied by the polynomial divided by the GCF. That quotient. So there's my polynomial. So I want the GCF outside, 3x squared, and I want the quotient inside. 3x squared divided by 3x squared. What is that? 1. 6x cubed divided by 3x squared, 2x minus 3x squared. Can you double check it to make sure it's right? Will you? Most likely not. But it takes 2 seconds. 3x squared times 1 is 3x squared. I'm right. 3x squared times 2 is 6x cubed. I'm right. 3x squared times 3x squared is 9x to the 4th. I'm right. That took 2 seconds. Your provincial exam gives you 10,800 seconds. Do you have 2 to spare? Yes. Trinomial. X squared plus, x squared plus bx plus c. That's what a trinomial looks like. It always ends up as x plus a number and x plus a number. Number 1 and number 2. And number 1 and number 2 are factors of C that add to B. Okay? We'll do examples in a minute. Difference of squares is a perfect square of any kind minus a perfect square. Oh my God, funny joke.
Wait,
What if you pour root beer into a square glass? What do you get?
Square root.
Beer.
No.
Root beer squared.
Oh,
The root of beer
Oh, I get that.
no.
of beer squared would be beer. Math geek jokes. Ben, you saying you get it first
Yeah, I got it.
makes you the #1 math geek.
Wait, what?
In this class, that's a good thing then. I complimented you.
It's a math nerd.
You got it first, and you do
Oh, I see.
And that always is the square root of the first one plus the square root of the second one times the square root of the first one minus the square root of the second one. Always. Okay, everybody good? So let's look at that. What are we doing? GCF, of course, Audrey. Why? It's not a trinomial, and they're not square roots. Audrey, it's just because I couldn't hear you. All I could do was see this, and I can't translate that. But you're right, it is certainly GCF. What is the GCF? 4? 2? AB. So, the answer is GCF 2AB, and then the quotient, 7A minus 4B. Okay? Over here, looks like a trinomial. 5, 3, 2. Better check. What's coming out of there? 9. And m squared. 9m squared, and then 3m cubed minus 2m plus 5. Now, this might be factorable, but not for you guys. Okay? If you get to there, you're okay. Cool? Okay. Factor the following trinomials. If you're good, you don't need to do all the steps, but of course, some of you may need to. I look at that and I say, what do I need? I need to multiply to 4 and add to 5. What is it? 4 and 1. Since they're both positive, x plus 4, x plus 1. Let's say you do it that way and you don't see that in the choices. What will you see? You will see x plus 1 and x plus 4. You understand they're the same thing, yes?
Yeah.
5 times 2 is the same as 2 times 5. Order doesn't matter. Be aware of that. Don't sit there at a question. My answer isn't there. When all they've done is switch the order. Okay? What about this one? I need to multiply to what? Negative 28. And add to what? Negative 3. What is it? 4 and 7. X plus 4, x minus 7. Easy to check. 4 minus 7 is negative 3. 4 times 7 is negative 28. Done. Blech! What don't I like about A? Give me one thing I don't like about A compared to what we've just done. There's a cubed. What else? Lita. Leading coefficient. What's the best thing to do to try and get rid of leading coefficients? GCF. Also best thing to do to get rid of cubes. Is there a GCF there? What is it? 2x. 2x leave me with 3x squared minus 10x plus 7. Yes? Now, a great many of you will stop there. Guess what choice A on the provincial will be? That. And a great many of you will circle it. Why is that a mistake? Because you haven't checked if this factors. This is the other kind of factoring. Remember, there's a shortcut. We follow the same rules. The only thing that's different is this 3 has to multiply by this 7. I need to multiply to what? 21 and add to what?
10.
Negative 10. Right? What is it?
Negative 10.
Negative 10.
Sorry, I was thinking.
Minus 3 minus 7, yes? So, I have x minus 3 divided by what? 3. Because that 3 was multiplying all the way through. Remember, we're factoring, so we're trying to get rid of it. And I have x minus 7 divided by what? 3. What do I do with that? What do I do with every single fraction I ever see in a math class ever? Simplify. 3 divided by 3 is 1. So I have x minus 1. What do I do with that? Does it simplify? So where does that 3 go? To the front. And I have x minus 1 and 3x minus 7. That will be choice B. Is that correct? No. Why? Because you forgot the 2x. Choice C will probably be right. Understand? Don't forget the 2x. So over here, you already know what to do. What do you do? Pardon? GCF. What is the GCF? 3x. Leaving me with x squared plus 3x minus 4. Factor it. 3x. What do I need to multiply to? Negative 4, and I need to add to what? 3. What is it? 4 minus 1. X plus 4, x minus 1. Done. Good? C. Blech. It's not a trinomial. So what do I got to do if it's not a trinomial? What's the first thing I try? What's the first thing I always try? GCF. What is it? 5n. 5n. 4n squared minus 9. Am I done? No. Is that answer going to be there? Yeah. Any of you going to circle it?
Probably.
Will it be right? Because isn't 4 a perfect square? And isn't 9 a perfect square? So it's 5n, square root of the first one. 2n, plus square root of the second one. 3. 2n minus 3. This one. It's trinomial. It doesn't begin with squared. And there's no GCF. So it's m squared. And I got to multiply it to 8 and add to negative 6. What is it? 4 and 2. Negative 4, negative 2, right? M squared minus 2. M squared minus 4. Choice A. Is it right? Nope. Why? There's a perfect square right there. M squared minus 2. M plus 2. M minus 2. Cool? Everyone's okay? Okay. Systems. We just did this. Okay? I would not like to waste your class time right now with this. Is that okay? I will put this on the video at the very end of today. Okay? Trig. Everybody wanted to see trig. Okay, this is the end of the video. Okay, so what I'm going to do is I'm going to pause it after this. I'm going to go back to the beginning with you guys and hit measurement and radicals and all that. Then I'm going to come back after that, unpause, and do that little bit of systems. So this video is totally whole. Okay? It won't be in the same order as the document if you download it off OneDrive, but it'll all be there. What do you guys know this theorem as?
Pythagoras.
But that's how you guys know it.
Yeah.
Right? And that's a real disservice. I know this screws you up because I gave you a question this year where I called this leg C. And way more than half of you got it wrong. Because you don't actually understand Pythagoras, you just know this. The actual Pythagorean theorem is the square of the hypotenuse of a right angle triangle is equal to the square of the other two sides. So what does that really mean? Not with letters. Leg squared plus leg squared equals height squared. It doesn't matter what letters the legs have. I have seen it on numerous provincials, calling this A, which makes this side little a, even though it's the hypotenuse. And then you do this work and you do it wrong. And guess what choice A is? That work done wrongly to trick you. Because let's be honest, is Pythagoras difficult? No, your calculator does it all for you. Right? So, in this question, if I told you that this was a blank, and I called this A, B, C, and I said solve this triangle, you would need to find that blank. And some of you would get tripped up and call that little a and then do it wrong. Because, of course, little a should be across from big A, shouldn't it? Okay? This question has been on many a provincial, with the triangle rotated around to fool you even more. Okay? Please don't fall for their chicanery, which is a $5 word for trickery. Don't fall for it. You know how to do it. So this, of course, would be just 8 squared plus 15 squared would get me the hypotenuse squared. Right? Which is 64 plus 225 h squared, which is 289 h squared, which is 17. Okay? Don't fall for it. Sine, cosine, tan. Do you have to memorize what I'm about to write here?
No.
Why?
Because the data book.
It's in your data book. But you don't have to know how to use it? Yes. Sine is O over H. Cos is A over H. Tangent is O over A. Now, armed with this knowledge and looking at this triangle, tell me, what? How are we back here and where did everything we wrote there go? We filled all that in, right?
Yeah.
I don't remember. Did you tap one of the things on the side?
What?
Did you tap one of the things on the...
No. Fortunately, it's on video and all that is still there. Okay. You know this to be 17 now, right? What is sine of C? The only thing you have to know in trig is what these words mean. Kelvin.
8 over 17.
8 over 17. Because opposite means you go across the triangle from where you are told to start. So what is the cos of C? 15 over 17. If opposite is across and the hypotenuse can't change, the only thing left is the one that's beside it, adjacent. And what is the tan of C? 8 over 15. What then is the sine of A? Kelvin.
15/17.
15/17 because I am at a different spot in the triangle. What is the cos of A? 8/17. And what is the tan of A? 15/8. Okay. Okay. Now, are these real life or math problems?
Yeah.
Math problems. In real life, you would have to find all this, wouldn't you? In real life, it would be, I'm building a house. Right? I'm building a house, this is my wall, it's got to be this tall, I'm not allowed to put a fence, I'm putting up a satellite dish, I have to have this much clearance from the fence, blah, 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 blah. What is the key to every trig problem? What must you have? A right angle triangle. Does it matter what it looks like? No. So just draw one. Okay? So, this one's drawn for you. What do I have? Do I have an angle? Yes. Theta equals 19. Do I also automatically know this angle? Yes, but I'm not going to use it because this one's given to me. If this is given to me, this is where I start. Okay? So this is where I find my opposites and adjacents and hypotenuses from. What do I have from here? I have an H and I need an O. My O is unknown. My H is 22. What do I use? Sine. Sine 19 equals O over H. Sine 19 is just a number. Do you know it? No. Do you have that value somewhere upon your person? Yes. This thing knows what that number is. Just like this thing knows that pi is 3.14159 and on and on and on to a billion decimal places. Do you know any decimal places of pi past 3.14159? No. You know it as pi. And you write it as pi. But you know that that's a number, 3.14159, and so on. This is...
Oh my god.
Mr. Myers, the read button too in that picture.
Pardon me, Joshua?
Try the read button.
Well, that's... I hit the undo button. There is no redo button. Oh, redo. No. Thankfully, I've been equipped with the finest in technology in order to teach you mathematics. Of course, you have sine 19 equals O over 22.
You should bring out with anybody there.
If this was 10 equaled x over 2, what would you do?
You multiply by 2.
So what are you going to do here?
Multiply by 2.
2 sine 19 equals x. Your calculator, you must figure it out. It is either 22 times sine 19 or 22 times 19 sine. What must you hit at the end? Equals. If you have a backwards calculator, at least 10 of you won't hit equals. sine of 19, whatever it is, 0.857 or whatever it is, will come up on your calculator, and you will circle that because they will make it one of your choices because they know that you are not paying attention. I am scared to write the right answer. I am going to do so though and risk it.
You should just
22
write out if anybody
times sine 19. 3.3. Okay. Over here, I have an angle. Do I have a theta? What is it?
34.
And I have an opposite of 56 and an adjacent of x. My hypotenuse is also unknown. Do I give a rat's patootie what the hypotenuse is in this question? No. So will I touch sine or cos with a 10-foot pole? No. Sorry, with a 3.3 meter pole because we are in Canada. No. So we will do tan of 34, and that will equal opposite 56 over x. When the x was on the top, we multiplied. When the x is on the bottom, we 56 divided by tan 34 equals. Now, I have gotten the number negative 89. Is that a possible measurement? No. So, what is wrong? Where are pitfalls in trig? Because I have done this on purpose. Because one of the choices will be negative 89. Why? Because my calculator is not in degree mode.
That makes much sense.
So when I put my calculator in degree mode, and I do, because this one was wrong too,
Yeah.
wasn't it?
Yeah.
So 56 divided by tan 34. 83.0. Now, this made sense because 22, that's a nice short leg. Nobody had any problem with me writing that, did we? Till Jason thought it to check it over. Because that's going to be there. But that's with my calculator in radians mode. The real answer is 7.2. Okay? I did this because I knew it was going to happen over here. Sometimes it's obvious your calculator is in radians mode. Sometimes it's not. Okay? On a multiple choice question, you're going to get 0 if you circle the wrong one, aren't you?
Yes.
If it was open-ended, I would give you almost full marks for setting this up, wouldn't I? I might take away a half mark because you're not in degree mode. So be careful. And finally, a wheelchair ramp is 7.5 meters long and rises 0.5 meters. What is the angle of elevation? Oh, angle. Oh, trig. Oh, what do I need? What do I need for every trig question? A triangle. So I draw one. Doesn't matter what it looks like.
No.
No. The ramp is 7.5 meters long. Where's the ramp? 7.5. Because if you're going up a ramp, you don't go along the ground and go straight up the wall, do you? You go up the ramp. And it rises 0.5. I want the angle of elevation. Which angle elevates? The one on the left or the one on the right? The one on the left. Why? Because I'm going up to the ramp. Right? Right? Now, if I finish this rectangle and I put a red line there, a green line there, a black line there, and a gray line there, what is the only one of those that is an angle of declination or depression?
Gray.
Kelvin? No.
Gray.
The gray one. Because me would be up there looking down. So this is the angle of declination. And it is opposite the angle of elevation. Many of you will do the angle of elevation questions using this as your angle of declination or depression. And the right answer will appear there if you use that. But that will be wrong. Does everyone understand that? Now, of course, the question becomes, do I have a theta? No, because that's what I'm looking for. I have an opposite, which is 0.5, and I have a hypotenuse, which is 7.5. What uses O and H? Sine. So sine x equals O 0.5 over H, 7.5. What finds me angles? Shift sign. And I punch that in my calculator. However it is you have to punch into your calculator. For me, it's shift sign, because I hit it first, bracket, 0.5 divided by 7.5, close brackets equals. And what do you get? 4 degrees. Is everyone okay with trig? Now, I could do 1,000,000 word problems, but there's no need, is there? Because every word problem requires you to do what? Draw a triangle. I cannot give you a word problem for every single situation in the world where a triangle can be drawn, can I? Because that would be an infinite amount of problems. All you must remember is you have to draw a triangle. Okay? The hardest trig question you got all year, I think, was the airport question, where the plane is somewhere over there. How far is it from the airport? And very few of you were able to understand that there's a triangle on the ground and a triangle in the air. And they both share one line. That is where you're going to screw up this scenario. A triangle up to the clouds. The clouds are green because it's LA. Okay? And that triangle goes along the ground and then up into the sky. But to know how far it goes along the ground, you have to do the triangle that is on the ground. Understand?
Yeah, I do.
Okay, it's very hard to draw in 2 dimensions. It requires you to think. Okay? Is everybody okay with trig?
This man.
Yes.
In trig, you always round up, right?
Round up?
Like,
No, you round to the appropriate number.
Well,
If
yeah.
it is 3.1, then you have 3.
Yeah.
If it is 3.8, you have 4.
Yes.
Rounding is not, there's no
Yeah.
exceptions to
I
rounding.
said that wrong.
So what do you mean?
Like, you always round.
Oh, for angles.
Yes.
Yeah, unless you need not. If the choices are going to the 100th, then you got to go to the 100th,
Yeah.
right?
Yeah.
But yeah, they'll tell you to the
Okay.
nearest degree. Okay?
Yeah.
Is everyone okay with that? That's the hardest kind of trig question, where there's two triangles together that are in different dimensions. Okay? Everybody cool? All right. So I'm going to pause my recording. Okay, everyone, we are just have systems of equations to review again now, since we just did this for a test. This won't take very long. I'll put it in right now, and then it'll show up at the end of the video. So graph the following. Y negative 4x plus 1, so I go up to plus 1, and I do a negative 4 down 1, 2, 3, 4, and out 1, and there's my line. Graph this guy. That's going to be 2y equals negative 3x minus 12, which is going to be y negative 3 halves x minus 6. So I go down to minus 6, 1, 2, 3, 1, 2, and there's that line. So to solve graphically, all we got to do is find the intersection point. Hey, Mr. Whitman.
I'm going to give you a tip. This is just
Okay, so we're going to graph these bad boys. Blue line, of course, 2y equals negative 2x plus 6. Y equals negative x plus 3. 1, 2, 3. Negative x, 1, 2, 3. There we go. So it's going to hit on all of these because it's got a slope of negative 1. Red line, 4y equals negative 3x plus 3. So y equals negative 3/4 x plus 3/4. Now that's difficult because it's plus 3/4. So since I've made the mistake of already graphing and I can't change my scale, I got to think about this. I can take this, and when I put it in slope-intercept form, it doesn't work very well. So I could do some y-intercept stuff because I know my slope, right? So I know my x-intercept is when y is 0. So I can go 3x equals 3 and x equals 1. So my x-intercept is 1, so I can go ahead and put a 1 right there. And I know my slope is negative 3/4. So I can go down 1, 2, 3, and over 1, 2, 3, 4. And there doesn't quite make it. And I can go up 1, 2, 3, and over 1, 2, 3, 4. Doesn't quite make it. 1, 2, 3, 1, 2, 3, 4. Doesn't quite make it, but you can see it's going to happen down here somewhere. 1, 2, 3, 1, 2, 3, 4. It's going to happen right there, just off the graph, which is 5, 6, 7, 8. 8, negative 6. Now, since it's off the graph, I'm going to want to check up here. So that's going to be 16 minus 12 is 4. That's not right. And that's going to be 24 minus 24. So that's not right. So this isn't going to work, is it? So since it's going off the graph, I got to keep checking. So what I would do in this case is, see, it all disappeared there. Something's wrong with my machine. What I would do here is I would scale it, right? I still had 2x, 2y equals negative 2x plus 6, y equals negative 1x plus 3, so plus 3. So don't draw it on there. Oh. Guys, I don't know what's wrong. It keeps disappearing. It was happening in the other class. I've got kids in here at lunch watching it right now, and they have watched it disappear on me twice. It is very frustrating. So I'm going to try a third time. It's probably not going to work. I had y equals negative x plus 3. So don't graph it yet. Scale it. And I had y equaled negative 3/4 x plus 3/4. So now I'm going to scale. So 1, 2, 3, 4. There is 1. So 3/4, 1, 2, 3. And out 4, 1, 2, 3. Negative, out 4, 2, 3, 4. There. Making that 1 for my red line. My blue line needs to have a slope of 1 with a y-intercept of 3. Yes? So that means as long as my slope is 1, I know it's going to be going
Maybe it's your pen. Maybe you gotta like.
No, it's not the pen.
Are you?